So 5 equals negative 1 squared is 1. 1 times 2 is 2, plus 4 minus c. So 5 equals 6 minus c, so c has to equal 1. The next one here, here's another tricky one, and we went over this one in most of your classes, but we'll take a look at it again, but I'll probably go quite quickly. So our goal here is to find r. So we know two things. We have sector area and arc length. So sector area, we know that that is a fraction of our area. So we can write it as theta over 360 times pi r squared, whereas our arc length is this fraction over 360 of our circumference. And now we talked about in class how we could turn this into radians, so our thetas and radians, and we could do theta over 2 pi times pi r squared, because then our pi over pi is 1, so we have 1/2 theta r squared. And our arc length, if we did the same thing and rewrote it with radians, is really equal to pi times r. So if we write that over here, we know our shaded area, 12 equals 1/2 theta r squared, and our arc length, 6 equals theta times r. We have a system of equations, and it just looks slightly different because we don't normally see them like this, but we can solve for, let's solve for our theta. So 6 over r is equal to our theta. And then if we plug that in, 12 equals half 6 over r times r squared. A lot of nice things happens. R, so half of 6 is 3, so 12 equals 3 times r, so r has to be 4. So it looks really challenging, but once we use those formulas, it turns out pretty nice. So the next one here, we have a graph, and it says the f of the opposite of x. So the opposite of x, 2, negative 2. 0 would stay, negative 4, positive 4. So then we have it there. 11b. Another graph can be written as g equals a times f of x plus b. So this is referring to our other graph here, and I'm going to write that so we add 2, 2, and negative 4, 1. So it's still referring back to this one, so our original. And what happened to the graph? Well, in words, it flipped, it got longer, and it moved to the right, and to the right 1. So to the right 1, that's this b value. So we know in there is going to be f of x plus, nope, right, so that would be minus 1. It flipped, so we have to have a negative. And this went from 2 down to 4, so twice as long, so it would be a negative 2. Find the number of roots for the equation. So if you guys remember, what tells us the number of roots is the discriminant. And if we were to plug that in, that would be q squared minus 4 times p times negative 4p. So simplifying this would be q squared plus 16p squared. And I would argue that this will always be positive, because when you square a negative, it turns positive. And since it's always going to be positive, there will be 2 real solutions. So the next one, find the y-intercept. Well, our y-intercept is when x is 0. So if we plug in 0, e to the 0, 5 times 0 minus 10 plus 3. Anything to the 0 power is 1. So 1 over, we'd have negative 10 plus 3. So this would be 2 and 9/10. Find the equation for the vertical asymptote. Vertical, we always look in the denominator. So when does that equal 0? So our equation would be when x is 2. 14. The following diagram shows the chord AB in a circle with radius 8 where AB equals 12. Well, this is kind of tough here. So we know a radius, so we could draw in a couple of radius here. So we know that this is 8 and 8. Find the area of the shaded. Well, we could do this as sector area minus the triangle. So we need to figure out that theta. So again, we could say a sector area, theta over 360 times pi r squared, so pi times 8 squared, minus our triangle. The area for a triangle is 1/2 2 sides times the sine of that angle in the middle. So this would be a calculator problem, and what we have to do is figure out theta. Well, we could use law of cosines. So we could say 12 squared equals 8 squared plus 8 squared minus 2 times 8 times the cosine of theta. So we have 144 equals, let's see, 64 and 64, so 128 minus 128 times the cosine of theta. So minus 128 minus 128. So we have 16 equals negative 128, the cosine of theta. Divide by negative 128. So 16 over negative 128 equals the cosine of theta. And then we have to do our inverse cosine to find our angle. And so 16 over 128. I'm going to switch this into degrees. Inverse cosine. 16 divided by negative 128. 97.2 degrees. So if we go back and plug that in, 97.2, and I'm going to leave you guys to do that. Pi times 8 squared, half 8 times 8 times the sine of 97.2. You would have your answer there. So this next one, number 15, at Grand Basin, the height of water is measured in meters. Okay, so we have a cosine equation, it looks like. So let's see what it's asking us to do. How much time is there between the first low tide and the next high tide? Next high tide. So here's our low tide, the next high tide. Time is x, so it would just be 6.25 hours. Find the difference between the low and the height. Well, let's see, 0.6 to 1.5. So that would be 0.9. I think they said it was in feet. Find the value of P. Well, P is our amplitude. Well, if the difference between the low and high is 9, so our amplitude would be 0.45. Because again, our amplitude is how far from the midline, so our midline is right through there. Because if you guys remember, so we have our high, our low, and then our mid going right through the middle. Find the value of Q. Q. So that's like we usually would say this is A, the cosine of B, X, and then we got a plus D. So that's our period. So 2 pi divided by Q equals our period. So I wonder if we can figure out what's our period. Well, how long does it take to get a full cycle? So from here to here, well, that's 12.5. So we can rewrite this as 2 pi divided by Q equals 12.5. So 2 pi equals 12.5 Q divided by 12.5. So 2 pi over 12.5 equals Q. Find the value of R. Well, what's R? That's the vertical shift. Well, let's see. We know from here to here is 0.45. So what is 6 plus 0.445? So 0.6 plus 0.45 is 1.05. So what is this final equation? I bet we'll need it for this next one. So y equals 0.45, the cosine, 2 pi over 12.5 x plus 1.05. There are 2 high tides on December 12th. At what time does the second high tide occur? So, let's see. Wait, what date do we want? December 12th. So that's quite a few days after this, because when is this? This is for 2100 hours. Military time. What time is 2100? Let's see. 24. That's 23, 22. Let's see. So 24 is 12. 23 is 11. 22 is 10. 21 is 9. So this is at 9 o'clock. So we have to figure out when are the next high tides. So when would those maximums be? Well, how often does a high tide occur? Every how many hours? It looks like here, every 12.5 hours. So we could make a list here. So at 9, was it a.m. or 9 p.m. was a high tide. And that was on December 10th. So we said a high tide occurs every 12.5 hours. Oops. So the next high tide, 12.5 hours later, would be at 9:30 a.m. on December 11th, because that would be the next one. 12.5 hours later would be 10 p.m. That's still December 11th. 12.5 hours later would be 10:30 a.m. on December 12th. And then 12.5 hours later would be 11 p.m. on December 12th. Geez, so we didn't even need the equation at all. We could just count them out there. So this next one, we're given two functions, so that f of g of x equals that. So we're trying to find f of g, which is x squared minus 2. So if we plug that into our f function, we have x squared minus 2 minus 1. So that is, but that would be squared minus 1. So we have x squared minus 2 times x squared minus 2 minus 1. So we have x to the 4th minus 2x squared minus 2x squared plus 4 minus 1. Simplifying, x to the 4th minus 4x squared plus 3. 16, we can cross out 16b. We're not going to worry about 16c. Let's take a look at the setup for this one. And I'm going to run out of time, so we might just talk about this one. So find dB. Well, dB right here, so we could use law of sines. The sine of 100 over 11 equals the sine of 59 over dB. Find dC. Well, once we find that one, we could use law of cosines. So this would be a law of cosines problem.